Hello and welcome back to Construction Fundamentals. Today we're diving deep into a crucial element of building construction that often gets overlooked, the Damp Proof Course, or DPC. Don't forget to like, share and subscribe to our channel for more insightful construction tips and tricks. Now imagine this, you've just built your dream home, everything is brand new, sparkling clean and ready for you to move in. But as the monsoon season hits, you start noticing damp patches on your walls, a musty smell in the air and the paint starts peeling off. This, my friends, is a telltale sign of rising dampness, a common problem in buildings that lack a proper damp-proof course. DPC acts as a barrier against moisture, preventing it from rising from the ground and seeping into the walls and floors of your building. It's like an invisible shield, safeguarding your structure from the damaging effects of water. In essence, DPC is a fundamental component of building construction, ensuring a dry, healthy and durable structure for years to come. In the upcoming sections, we'll delve into the specifics of DPC, exploring its types, materials, installation process and the numerous benefits it offers. So stay tuned and discover why DPC is a must-have for any construction project. Having understood the basic concept of DPC, let's now understand why it's so crucial for your building's structural integrity. Imagine water slowly creeping up the walls of your home, silently weakening the very foundation it stands on. That's precisely what rising dampness does. Moisture, if left unchecked, can wreak havoc on your building's structure. It can weaken the mortar, corrode the reinforcement within concrete, and even cause timber elements to rot. This can lead to structural instability, cracks in the walls, and even, in severe cases, collapse. DPC acts as a barrier, preventing this insidious damage. By stopping the upward movement of moisture, DPC protects the load-bearing components of your building, ensuring its strength and longevity. Remember, prevention is always better than cure. Investing in a proper DPC during construction is far more cost-effective than dealing with the extensive and expensive repairs that moisture damage can cause down the line. Beyond safeguarding your building's structure, DPC plays a crucial role in enhancing its durability and ensuring a healthy living environment. As we've established, moisture is the enemy of any structure. Apart from structural damage, dampness also leads to several other issues, impacting both the aesthetics and longevity of your building. Think unsightly mold growth, peeling paint and wallpaper, and a persistent musty odor. These are not just aesthetically unpleasant, but can also lead to health problems, especially for people with respiratory issues. This is where DPC steps in, acting as a shield against these moisture-related woes. By preventing dampness, DPC safeguards your interior finishes, prolonging their life and reducing the need for frequent repairs or replacements. Furthermore, a dry home is a healthy home. By keeping moisture at bay, DPC contributes to better indoor air quality, reducing the risk of mold growth and allergens, and creating a healthier living environment for you and your family. So DPC is not just about structural integrity, it's about preserving the beauty, longevity, and health of your building. Now that we understand the importance of DPC, let's delve into the different types of DPC commonly used in construction. DPC can be categorized based on their location within a building. The most common type is horizontal DPC, which is laid horizontally across the width of a wall at a specific height above ground level. Then we have vertical DPC, applied vertically to protect basement walls and retaining walls from lateral water penetration. This is particularly useful in areas with high water tables or heavy rainfall. Moving on, we have floor DPC, which is laid beneath concrete slabs and floor finishes to prevent moisture from rising from the ground. Similarly, roof DPC is installed in roofs to prevent water ingress and protect the roof structure. Lastly, basement DPC is a specialized type of DPC used to waterproof basements and underground structures. Choosing the right type of DPC depends on the specific requirements of your building and the potential sources of moisture. Section 5, Material Matters, exploring flexible and rigid DPC options. Besides location, DPC can also be categorized based on the materials used. Broadly, we have two main types, flexible DPC and rigid DPC. Flexible DPC, as the name suggests, is pliable and can be easily bent or molded to fit different shapes and sizes. Common materials used for flexible DPC include bituminous felts and plastic sheets. These are typically used in horizontal applications, such as in walls and floors. On the other hand, rigid DPC is more robust and inflexible, typically used in situations requiring higher strength and resistance to water pressure. Materials like metal sheets, slate, and dense concrete blocks fall under this category. They're often used for vertical applications, such as in basements and retaining walls. The choice between flexible and rigid DPC depends on factors like the location of application, the level of water pressure expected, and the structural requirements. Section 6, DPC by function, integral, surface treatment and cavity wall solutions. Beyond location and material, DPC can also be categorized based on their function and how they prevent moisture ingress. One type is integral DPC, where the damp-proofing agent is mixed with the building material itself, such as concrete or mortar. This creates a homogeneous barrier against moisture within the building element itself. Then we have surface treatment DPC, where a waterproof coating or membrane is applied to the surface of the building element. This is a common method for treating existing dampness issues. Finally, cavity wall DPC is a system used in cavity wall construction, where a DPC layer is placed within the cavity between two walls. This prevents moisture from bridging the gap and penetrating the inner wall. Understanding these different DPC types based on function can help choose the most effective solution for your specific construction needs. Section 7. The building blocks of DPC, common materials used. Now let's explore the common materials used to create these moisture-resistant barriers. One of the most traditional and widely used materials is bituminous felt. It's a cost-effective solution, readily available and easy to install. Then we have plastic sheets like polyethylene and PVC, which are gaining popularity due to their durability, flexibility, and resistance to rot and decay. For applications demanding higher strength, metal sheets made from materials like copper, lead, and galvanized iron are used. In some cases, cement concrete, with its inherent water-resistant properties, is used for DPC, especially in foundations and basements. Bricks, specifically engineering bricks known for their low porosity, are also utilized in certain situations. For a more natural approach, stones like slate and granite, known for their impermeability, can be used as DPC. Lastly, chemical treatments like silicon-based solutions are injected into walls to create a damp-proof barrier. Section 8. Laying the foundation of a dry home, the DPC installation process. While we've discussed the various types and materials, understanding the correct installation process is equally crucial for DPC's effectiveness. The process begins with site preparation. The area where DPC is to be laid needs to be cleaned, leveled, and free from any sharp objects that could potentially puncture the DPC material. Next comes material selection. The right DPC material should be chosen based on its location, the type of construction, and the expected level of water exposure. The application process involves laying the DPC material over the prepared surface, ensuring it's continuous and free from any gaps or tears. Overlapping joints is crucial for a watertight seal. The DPC layers should overlap by a specific amount, typically recommended by the manufacturer, and sealed properly using adhesive tapes or sealants. Finally, curing is essential for some DPC materials like cement concrete to achieve their maximum strength and water resistance. Remember, proper installation is key to ensuring the long-term performance of your DPC system. Section 9. Conclusion: DPC, a small investment for a big impact on your building's lifespan. In conclusion, DPC, though often unseen and overlooked, plays a vital role in safeguarding your building from the damaging effects of moisture. It's a small investment during construction that yields significant returns in the form of a durable, healthy, and long-lasting structure. Remember, preventing dampness is far easier and more cost-effective than dealing with its consequences later. So whether you are constructing a new building or renovating an existing one, make sure to prioritize the inclusion of a proper DPC system. Thank you for joining us on Construction Fundamentals. If you found this deep dive into the world of DPC insightful, don't forget to like, share, and subscribe to our channel for more construction-related content. Until next time, stay dry and build strong.